The title you've heard is When Gold Standards Are Not So Golden, and I'm trying to give a critical appraisal of the evidence on the effectiveness of colorectal cancer screening from randomized trials and observational studies. Yeah, some very brief introduction on the descriptive epidemiology of colorectal cancer. As most of you may be aware, it's the third most common cancer globally, approximately almost 2 million new cases each year. And in terms of cancer deaths, it's even number two, more than 900,000 deaths from colorectal cancer each year. Some short notes about the natural history and clinical features of colorectal cancer. The mean age in high-income countries is more than 70 years, but the growth and development of the cancer starts much earlier. In most cases, there's a quite slow development through the so-called adenoma-carcinoma sequence, which takes usually many years, if not decades. And even if the cancer is already present, there's usually a preclinical sojourn time of approximately 3 to 6 years before it's being diagnosed. And at the same time, we know that prognosis strongly depends on the stage the cancer is diagnosed. The 5-year relative survival rates in the US, they range from more than 90% among those with the localized disease to less than 20% among those with distant cancers. And taken together, all this means that in principle, there should be excellent preconditions for screening. Well, what offers or what types of screening options do we have? A couple of years ago, a work group at the International Agency for Research on Cancer, the IARC in Lyon, convened and came out with this big handbook and summarized the results in the New England Journal. Essentially, there was stated that there are 3 established ways to do screening. The first would be the fecal occult blood tests, the older Guaiac-based tests, and the newer immunochemical tests, often called fecal immunochemical tests, or abbreviated FIT. They are recommended annually, usually in the United States, biannually in most of Europe. Then there are the endoscopy methods, the flexible sigmoidoscopy that is usually recommended every 5 years, and the full colonoscopy usually recommended every 10 years. And the big advantage of these endoscopic exams is that one can directly visualize the large bowel. For flexible sigmoidoscopy, it's approximately 1/3 of the large bowel only, but it's the distal part where approximately 2/3 of the cancers are located. And for colonoscopy, one can visualize the entire large bowel. Well, the difference is, of course, that the sigmoidoscopy is much less invasive. It doesn't require the full bowel cleansing, starting the day or even days before. Usually does not need any sedation, has extremely low, if any, complication rates. And colonoscopy, of course, is a bit more invasive, more costly, of course, also. But I said one can visualize the entire colon and rectum and take away the precursors of colorectal cancer, the adenomas, in most cases. But for evidence-based medicine, we usually require for screening methods like for other procedures that there should be RCT evidence from randomized controlled trials. And fortunately, we have such evidence for the fecal occult blood tests. Essentially, since the 1990s, there have been a couple of RCTs both in Europe and the United States. For sigmoidoscopy, evidence is available from 4 large randomized trials, and long-term results have first been published in 2010, so quite some time ago. But for colonoscopy, actually, the first RCT evidence on long-term effects was reported only relatively recently in October 2022, so less than 2 years ago. But let me start with a look back in history regarding the evidence for effectiveness of colonoscopy screening. This is a publication in the New England Journal in December 1993 from Sidney Vinaver and a colleague from the National Polypectomy Study. This study was actually an RCT also, but this RCT compared actually different surveillance schemes after colonoscopic polypectomy, and sort of as a side result, this observational study on the long-term outcomes after polypectomy was performed in the sense of an observational epidemiological study. And what the authors did is they followed this cohort who had a polypectomy in this study and looked at the cumulative incidence of colorectal cancer over approximately 7 to 8 years, which was very low. And then they compared this incidence to the cumulative incidence of the average risk population. They took data from the SEER program in the United States. This average risk population, of course, includes people who have polyps and people who do not have polyps. In this cohort here, these were exclusively people with polyps, so people who in principle would have had a higher risk, but these polyps were removed. And after that, they had a substantially lower, 76% lower risk than this average risk population, despite being in principle a high risk population. And this comparison, of course, was adjusted for age, sex, and the regional usual suspects we have to control for. And then the authors did something else. There was a historical cohort from the Mayo Clinic, also people who had polyps in the colon and rectum, but these polyps were not removed. This was a cohort recruited in the 1980s when colonoscopy was not widespread available. And at that time, one just did a follow-up by radiological examinations. So in principle, the baseline risk should have been similar in this cohort, like in this cohort. So all of these had polyps. Here, the polypectomy was done, and here you can see a difference of 90% lower risk in those with a polypectomy. So quite impressive results from my point of view, and obviously also impressive for many people in the United States. Here you see, this is from a doctoral student from our group, a review on what is known about how much different screening tests were used over the years in the United States for colorectal cancer. And you can see that already in the 1980s and 1990s, there was quite some screening going on. Red is screen use overall, but at that time it was mainly sigmoidoscopy and fecal occult blood tests. But approximately starting in 2000, there has been an enormous increase in colorectal cancer screening use in the United States, and this was mainly driven by a substantial increase in use of colonoscopy. These are proportions of people here in the yellow circles who have had a colonoscopy in the last 10 years in the respective age groups for which screening is recommended. So actually a majority of people in the United States in this age group have had this, and the other screening tests, their use went down a little. And here you see some, again, quite impressive developments of colorectal cancer incidence in the United States. Both for men and for women. For men, it was always higher than for women. Also, mortality rates went down. You see that there was already quite some decline in the 1980s and 1990s, possibly related to these earlier screening approaches. But then after a short increase, approximately around 2000, which could mean that it was the detection of many prevalent cases when screening colonoscopy was introduced, much more than it was used before. But in the following years, again, a dramatic decline in colorectal cancer incidence. And here you can see again how quickly and dramatically the use of colonoscopy, this is used within the last 10 years in the respective age groups, went up between 2000 and 2020, and at the same time this dramatic decline in the incidence rates. And the interesting thing here is that these developments were not at all homogeneous across age groups. By contrast, in the age group below 50 years, where usually no screening has been done, at least during these years, there has been an increase in colorectal cancer incidence rates across essentially all stages. And this major decline we have seen here, this was selectively seen in people above age 50. So that is the group of people in whom screening was done quite a lot. So you could argue, well, maybe such developments would have been seen in anywhere else. It may have to do with lifestyle factors or whatever. But if you look at countries that in the same time did not engage in any screening, and there were such countries in Europe, for example, essentially all the Nordic countries, Denmark, Norway, Sweden, during all these years, they waited with introducing any colorectal cancer screening. And during the same period here, between 2000 and 2020, there had been an increase in incidence rates before, and this increase was further ongoing during these years. And in many other respects, I think lifestyle factors and so on, they would probably not be too different from the United States. But then also in the meantime, there have been, of course, many or quite a number of observational epidemiological studies intrigued by these findings from the National Polyp Study, I'm sure. And also, I just show one example here from Harvard, the study based on the Nurses' Health Study and the Health Professionals Follow-up Study was a cohort analysis including almost 90,000 participants who were followed over a period of 22 years, and also published in the New England Journal. Here you see some main results. First, on the incidence of colorectal cancer. Let's first have a look at comparison of those who did not have any endoscopy with those who either had a negative sigmoidoscopy or a negative colonoscopy. These results actually do not tell us anything about screening effects, because these were the negative endoscopy. These were the people with no polyps. They were at inherently low risk. No polyps were there. No polyps were removed. So this doesn't tell us anything about any screening effects. But then we have the group of people with the polypectomy, in principle, people with increased risk, and the polyps were removed. And despite the originally increased risk, in the long run, these people then have a substantially reduced colorectal cancer incidence. And also the analysis on mortality here, and here we can also see a very clear effects that those who had a screening colonoscopy or a screening sigmoidoscopy or a screening colonoscopy, they had a substantially 40 to 70% lower colorectal cancer mortality than those with no screening endoscopy. Yeah, also around the same time, also published in 2013 in the New England Journal, one example of an RCT, one of the RCTs on fecal occult blood tests. In this example, the trial from the US, the Minnesota trial, also a huge trial, almost 50,000 participants, aged 50 to 80s. And here you can also see the time dimension of such trials. The recruitment had taken place in the 1970s. These main results published in 2013. So sometimes these trials take really a long time to show the important and main results, but here they are. And overall, after these 30 years of follow-up, then there was a 20 to 30% a reduction in colorectal cancer mortality in those who were offered either annual or biannual screening. Then also around the same time in 2014, there had been quite a number of RCTs on flexible sigmoidoscopy, overall 4 RCTs published, and quite a number of observational studies on the effects of screening sigmoidoscopy or colonoscopy. And we tried to review these studies and do a meta-analysis at that time. And here you see some summary results from this work. Here, first the overview on the randomized trials on flexible sigmoidoscopy. As you can see here, they were conducted in 4 different countries. The United States, this was the PLCO trial, and then 3 large trials from Norway, UK, and Italy. As you can also see, all of them with huge participant numbers ranging from somewhere around 50,000 to almost 200,000. While the intervention was usually a once-only flexible sigmoidoscopy at the age of 55 to 64, the US trial was a little bit different with a broader age range and also the offer of a second flexible sigmoidoscopy. The follow-up was at that time in the range of approximately 10 years. The main results are summarized here. First, in the usual intention to screen analysis of the RCT, so comparing the invited group with the non-invited group. And here overall, there was a modest but clear and significant reduction of colorectal cancer incidence at any site, approximately 18% reduction. And of course, this reduction was much stronger for distal colorectal cancers. So that means for cancers that were of the part of the colon and rectum that can be visualized by flexible sigmoidoscopy. And for mortality, there were also quite some relevant reductions seen, of course, mostly here for the distal cancers again. And then looking at the protocol analysis, that means those who actually went to screening with the control group, essentially. Of course, then the effects are stronger for distal colorectal cancer, reduction of 42% in the pooled analysis, and for the mortality then even stronger. At that time, there were no results from any RCT on screening colonoscopy, but what we did at this time, we then did the meta-analysis for the RCTs for sigmoidoscopy. We did a meta-analysis of the observational studies, the cohort studies on flexible sigmoidoscopy. We saw that overall the results were quite comparable, actually. And then we said, well, if there are no RCT results for colonoscopy yet, let's at least summarize the observational studies on colonoscopy. And this is what we did here. And we actually found quite a strong reduction for at least for the mortality in outcomes in these colonoscopy studies in the order of 70%. But then we had to wait almost 10 more years until finally, in October 2022, the first long-term results from an RCT on colonoscopy have been published. This was the so-called Nordic study. It's the first and so far still only RCT with published results on this screening intervention. Nordic stands for Nordic European Initiative on Colorectal Cancer. It was designed as a so-called pragmatic randomized trial. Overall, almost 100,000 men and women aged 55 to 64 again were randomly selected from population registries. Exclusion criteria were a previous diagnosis of colorectal cancer and a previous colorectal cancer screening. The recruitment took place from 2009 to 2014 in 4 countries: Poland, Norway, Sweden, and the Netherlands. But the data from the Netherlands, for confidentiality reasons, could then not be included in the analysis that was published in 2022. The randomization was a 1-to-2 randomization, 1 per 1 participants in the screening colonoscopy group, 2 participants in the usual care group. And the follow-up was done by record linkage with cancer and mortality registries in the participating countries. The primary endpoints were colorectal cancer incidence and mortality after 10 years and later on again after 15 years of follow-up. And the secondary endpoint was total mortality. The results published in 2022 refer to the 10-year follow-up data. So here you can see some key results from this study. First of all, the uptake of colonoscopy was a little bit less than was hoped for, only 42%, but it was very different between the countries. Actually lowest in the Netherlands, 23%, but Netherlands were not included in the final analysis. The 2/3 of the participants were from Poland, where participation rate was 33%, and in Norway it was 61%. And then you see the usual things for such an RCT. While looking at the cumulative incidence and mortality, first in an intention to screen analysis, comparing those who were invited to the control group. And here the relative risk for incidence was 0.82, meaning an 18% reduction of risk, and in the adjusted protocol analysis, a relative risk of 0.69. That means a 31% risk reduction. For mortality, well, overall the case numbers were still quite small, and results were look a little bit weird, with very small and non-significant reduction in the intention to screen analysis, and a very large effect actually in the adjusted protocol analysis. But in further sensitivity analysis on this, again, quite different results came out with partly extremely wide confidence intervals, probably simply due to the small numbers of cases yet. But overall, this was the, if you wish, the RCT proof that in the intention to screen analysis, that screening colonoscopy reduced colorectal cancer incidence, but overall, this result was largely disappointing after all the results one had hoped for. After the National Polyp study, after all these observational studies, one had actually expected that the results should be much stronger. And it's really worth to have a somewhat closer look at these data, which we tried to have here. And here you see the cumulative incidence curves over the 10 years of follow-up. On the left from the intention to screen analysis, on the right from the adjusted per protocol analysis, the curve for the intervention group and the curve for the control group. And in both types of analysis, there's a first phase where the intervention group seems to have a higher cumulative incidence then the curves cross after approximately 6 years, and only after that there's a lower incidence in the intervention group. Yeah, similar so in the protocol analysis, but a somewhat a different look at this would be the following. Of course, these higher risks in the initial years, they are not truly a higher risk. And what happens here is that the prevalent cases that are already there, and remember, the mean sojourn time is 3 to 6 years for colorectal cancer, so there are quite a number of prevalent cases to be expected. They were detected at a screening colonoscopy, which leads to this apparent increase, what is called cumulative incidence, but in principle is sort of a mixture of prevalence and incidence that is seen here. And very roughly speaking, we have a first phase of the follow-up, approximately 6 years, where we have mostly we deal with prevalent cases, especially in the intervention group, but also most of the cancers that will be diagnosed in the control group most likely also had been there already at recruitment. And then we have a second phase where we have mostly incident cases, when essentially most or almost all of the prevalent cases have become clinically manifest. And in this phase, where we really deal with incident cases, we have a very strong difference between the curves with a risk reduction of more than 50%. One could also interpret this earlier phase as a phase where we have much earlier diagnosis of the prevalent cases by in the screening group, and on average, as you can see here from these pictures, this is approximately 3 years earlier. But as epidemiologists, we of course should not do only such rough comparisons based on these curves. We should do some calculations, and here I'll try to guide you through some of such calculations. As you have heard, there was a 2-to-1 randomization, approximately twice as many participants in the usual care group compared to the intervention group. In the usual care group, over 10 years, there were 622 CRC cases observed. Half of them would have been expected in the intervention group due to this 2-to-1 randomization if the intervention would not have had any impact. But in fact, only 251 cases were observed in the intervention group. That means there was a difference of 311 minus 259. That is 52 cases, and this would be the prevented cases by in the intervention group overall. And the only assumption we need for making or drawing this conclusion is that in principle there was an equal risk in the intervention group and in the control group, and this is the usual RCT assumption that we always make in any RCT. But now let's have a closer look at these 259 cases that were observed in the intervention group. Of course, there was the majority of the intervention group did not go to screening, 58% did not go. And in this group, there were 157 CRC cases. And among those who went to screening, there were 102 CRC cases. And we also learned from the publication that of these 102 cases, 62 were early detected at screening. So that means they were definitely prevalent cases which were already there and by no means could have been prevented by taking away adenomas or whatever. So they were already there. But there were still another 40 cases that still occurred despite the screening. Now the second assumption comes in. Well, I think it's quite reasonable to assume that the prevention of incident cases by removal of adenomas, of precursors of colorectal cancer, can only have happened among those who actually went to screening colonoscopy. So what we I would call this a sort of a common sense assumption. And if one makes this assumption, we can see that overall among the screening participants, we would have expected 62 prevalent cases, 40 still incident cases, and 52 prevented cases. And that taken together, we would have expected 154 CRC cases in this group. Among these, the 62 have been early detected. That is 40% of the number we would have expected otherwise. 52 have been prevented. That is 34% of these 154. And taken together, this means 114, and this is overall 74% were either early detected or prevented. Both, of course, highly desirable effects of screening. One can also make another calculation and say among the really potentially incident cases, those who were prevented and those who were still occurring as incident cases, 52 out of these overall 92 incident cases were prevented. That means 57% of the preventable, in principle preventable cases were prevented. And in a way, you can then see here the official results from the publication in the New England Journal, stating that in the per protocol analysis, comparing those who went to screening with control people, there was a 31% risk reduction. But this is really includes the prevalent cases that could not possibly have been prevented. If we focus exclusively on the incident cases, those who are at risk and who in principle could have been prevented, we arrive at an estimate of 57% at very simple and basic assumptions that I have shown you a moment ago. But there were some further issues in this RCT, which I would like to share with you in a few more slides. As I have told you before, the exclusion criteria were those who died before the inclusion, and that's natural. They could not have been included anymore. And of course, those with a prior diagnosis of colorectal cancer should also be excluded. And yeah, since this was a randomized trial, one would of course expect that also the exclusions would be equally common in the intervention group and in the control group. This was approximately the case for the exclusions from of people who died, but it was not the case, and it was actually statistically significant for the exclusions due to a prior diagnosis of colorectal cancer. Should not have happened. It's about a randomized trial, so something went perhaps wrong here. And if one knows how dates of diagnosis are recorded in cancer registries, and that these dates there's a rule that these dates are to be updated once final histological confirmation is there. It can happen that the dates they change over time, and it could have happened, and I don't have the time to go into to this in detail, that actually some of the colorectal cancer cases in the intervention group in a way moved from pre-recruitment to post-recruitment, causing this somehow unexpected a difference here, or one could also call this a difference of 25 potentially missed exclusions in the intervention group. And if one accounts for this difference, this unexpected difference, and does the same type of calculations I just showed you before, then one would even arrive at an estimate of 66, not only 57 prevented incident cases. But let's have a look at these exclusions again. Why have there been such exclusions at all? If the cancer registries were perfectly up to date with their diagnosis, the registration of diagnosis, and at the time of randomization, it was checked with the cancer registries which diagnoses are known, and people who already had a diagnosis, they were no longer eligible for randomization. But later on, these approximately 200 people were identified with a prior colorectal cancer. And this, of course, happens because cancer registry data are not fully up to date. It always takes some time until they get the notifications. Then they have to do the recording of these notifications, enter them into their data set, and so on. And we try to estimate by how much approximately could have such registration be delayed. And what we did is we took cancer registry data from the 3 countries included in the study, and looked at the age groups involved and so on. From these data, we estimated that there should have been approximately 80 colorectal cancer cases per year in this study population of 84,000, which means if there were 221 such post-randomization exclusions, this could correspond to approximately 2 to 3 years delay in cancer registration. This is actually not too surprising, because from a vast literature in cancer registration, we know that this is on average, it's something like 2 to 3 years that has been reported also elsewhere. But now, of course, cancer also the follow-up was made by record linkage with cancer registries. And here again, the delay in cancer registration might play a role. Let's look at the data from Norway. After 10 years, this population with an initial mean age of 60 in the control group, they had a cumulative incidence of 1.6%. But if we look at data from the Norway Cancer Registry and we estimate the 10-year cumulative incidence we would expect between ages 60 and 70, so mean age 60 was the starting age here, and then we would have expected overall 2.2% cumulative incidence. Again, an indication that the incidence here was substantially lower, and this difference again would be compatible with a delay in registration in the order of 2 to 3 years. So probably the follow-up of cancer cases was not really complete. And if we then know that the risk reduction actually emerged not evenly over these 10 years of follow-up, it just emerged between 6 and 10 years of follow-up in these 4-year time windows, then a delay of a registration or notification of the cases by 1, 2, or 3 years actually can make a lot of difference. It would mean that it could mean that 25, 50, or even 75% of CRC cases in this time window might not yet have been fully registered. It could mean that the risk difference that is exclusively observed in this time window may be substantially underestimated, and conversely, the numbers needed to invite or numbers needed to screen would be substantially overestimated. And there's one more issue I would like to address here is that there's also some sort of contamination, even in Norway, Poland, and Sweden, where no screening colonoscopy was officially offered during the years of recruitment and follow-up. Of course, some proportion of the population had screening colonoscopies in this time, in this age group. These are data from a European Health Interview survey showing that we are between 20 and 40% of people in these countries had some colonoscopy within 10 years. So, well, if we believe that the New England Journal of Medicine only it gives us the best possible data on screening measures we can have, we have different authors here in the New England Journal. We had already in 1993 this publication from Winover and colleagues suggesting a really strong effect of polypectomy by screening colonoscopy. And we have almost 30 years later these RCT results overall suggesting a very, very modest effect. Well, I dare to ask the question, is RCT evidence by itself always really the gold standard, and do we always really have to wait for RCT evidence? There's, of course, no doubt that RCTs are the gold standard when it comes to prevent confounding. That is one of the major issues we deal with in epidemiology, but I think there are a few other aspects that also need consideration. Here, a summary again of what happened in the United States, where one did not wait for the RCT results with colorectal cancer incidence rates, and in Norway, where one waited for the RCT results for 30 years. And in this case, I think the price for waiting so long has been quite high. The Nordic study by no doubt has a lot of merits. It's the first RCT evidence that demonstrates reduction of the incidence by screening colonoscopy. But of course, there are also some downsides which we need to keep in mind. First of all, it came approximately 30 years after we had already quite compelling evidence that screening colonoscopy is most likely very effective, and also at least more than 10 years after compelling evidence for by other sources on flexible sigmoidoscopy from observational epidemiological study on colonoscopy and so on. And even though its strengths are really the prevention of confounding, RCTs also can be subject to biases, different types of biases. I've tried to show you in this case the role of prevalence bias by including prevalence no longer preventable cases in the effect estimates. I've shown you possibly impact of a differential exclusion of prevalent cases, something we would call selection bias in usually in epidemiology, and epidemiologists care a lot of this normally in their study. There could also be issues of incomplete case ascertainment. In epidemiology, we usually call such problems outcome misclassification, and in this case, it could even have been differential outcome misclassification. And we also have some issues on contamination, which in epidemiology we would usually call exposure misclassification. In this case, also probably was a differential. So no doubt, large RCTs are the gold standard approach to prevent confounding in cancer prevention, in screening, elsewhere, but there are some possible downsides, and sometimes they can even be more prone to other bias. And the lesson for me here is that we simply should overcome the dichotomy saying, well, RCT is always the complete truth, observational studies are always prone to bias. We need the same culture for RCTs, very carefully looking with eyes of epidemiologists of what the RCTs really tell us, which biases could potentially play a role. And if we take this seriously and look ahead and enhance our culture of critical appraisal of evidence from both observational and epidemiological studies and RCTs, then I think we'll get the best possible judgment of the evidence. And with this, I think I probably should end to leave at least some time for questions. Here are some hints to some papers we have written on these issues. And with this picture from Heidelberg, I would really like to end and thank you for your attention.